हेलो
या नमस्कार डिमरी साहब, नमस्कार कुलश्रेष्ठ साहब।
नमस्ते नमस्ते, बहुत अच्छा वेलकम और मीटरोलॉजी डे की बधाई। हैप्पी मीटरोलॉजी डे टू ऑल।
आप सभी को भी बधाई।
So if you say, then shall I start now?
Yeah, we can start.
Yeah. So good evening everybody. It's my pleasure to welcome all of you for this Meteorology Day. It's a globally celebrated World Meteorology Day. Started in 1950. It's a very old one, and that's why it has contributed very accurate science in terms of weather, especially the precipitation and wind trajectories. I, on the outside of this, welcome our panelists, eminent panelists and students. Those you are connected with this or you what call Facebook. This Meteorology Day is, as usual, we are celebrating different days under ENVIS program. We have Ministry of Environment and Forest Climate Change funded program ENVIS. I am the coordinator. So we have this every time, whatever important dates are there, we are celebrating, and this is one of that events. We thought of celebrating and inviting very eminent people who can give some kind of tips regarding meteorology, the basics and application part, so that our student can be benefited. This is basically the day is related to weather, and this year theme is weather and climate and ocean. So very much relevant to the panelist specialization. Very carefully we select, and let me tell you, my selection has got one kind of very standard criteria. I keep three generations: one very old one, like Dr. Mohapatra, then middle one, Dr. Ganguly, and then young holistic leader, Mudita Chaturvedi in this panel. She is a PhD student of mine. So what I do here, we have just to introduce to new people. I have started after my teamship program, Young Holistic, as a part of our outreach program of School of Environmental Sciences. Young Holistic program is all about to have all-round development of the student, including academics and also leadership, giving them platform to perform and organize events. So it has been very interesting and encouraging for all of us to have this very active people involved in this. Now coming to WM Day. And this day is basically important for me also because I have been part of both meteorology and meteorology. By chance, after basically I am chemist by master and PhD, but after that I was associated with very renowned meteorologist, Professor Henning Rode in Stockholm University. He was my mentor. He has been my mentor and also associated with different programs where I was also involved in that. He was director of International Meteorology Institute. So my postdoc training has been in chemical meteorology. And if you go and consult our paper, in the beginning we have published several papers on trajectory, chemical component traveling from Europe and Middle East to India, several papers. So like LR TAP, which is the treaty convention in Europe, long range transport for air pollutants, I have suggested several times to have this kind of treaty in South Asia on the SARC, under the SARC framework we can have, and also we need to quantify that pollution what we are importing and what we are exporting. Say the need. So many times I have written even the ministry, IIT, so I feel in a due course of time, we have Dr. Mohapatra here to convey this should be done, because this is another area where we don't know how much anthropogenic and natural light jet aerosol we are. This quantification is required, and also the compensations nearby transboundary neighboring countries, what we can do. This should be discussed in policies, and also accordingly we have to choke out a regional plan in that. Now, not going, and one more thing I would like to highlight about, because since I am also involved in meteorology, that camel right push, one I have defined about the diffusion and transport of air pollution in Indo-Gangetic Valley, because the meteorology and topography of this region very much favor to diffuse this pollution. The stagnation will never be there within 8 to 10 days, and I have written, and that have been practically also it has been proved that this topography is plain, and plain topography in camel ride that the air comes, another throw come, and this pushes. Even high speed westerly, when they come down and comes almost 20, very less. This camel ride push, throw and next throw, then the air mass is they hit Himalayas and they are diffused to Bay of Bengal, that kind of thing I have done. So now coming to again welcoming our guest and now formally introducing our first panelist, Dr. Mohapatra. Dr. Mohapatra is well-known meteorologist. He is presently the Director General of India Meteorology Department, very renowned and very fine network. It's very old and very fine network like railway and post office. So he has a lot of responsibility for infrastructure management and also for empowerment. A lot of people involved in weather. His areas of interest are the forecasting, cyclone warning, cyclone disturbances, rainfall and thunderstorms, and forecast verification. He is having so many laurels, honors. He is honorary doctor of science from FM University, Balasore. He's fellow of Indian Meteorology Society, fellow of Indian Climate Congress, and so many papers he has published, more than 80. You can see his website, you will find. But here I welcome him. I just want he need to brief our students as a panelist what is now meteorological mission, especially the new projects where the students can focus and target and also dream to be part of such projects, and also what new technologies and tools are available with the IMD or India, so that our unusual event forecast, extreme events, and even the ocean management system. And so these things, if we know, probably our School of Environmental Science student can take benefit of its ideas and research what he shares with. Now I request Dr. Mohapatra. Mohapatra, so please.
Namaskar, good evening. Professor Kulshrestha, Professor Dimri, Dr. Ganguly, our dear student, Ms. Mudita, and Program Officer, Ms. Swati. Dear friends and colleagues participating in this event, ladies and gentlemen. At the outset, I congratulate Professor Kulshrestha and the entire team for organizing this webinar on the occasion of World Meteorological Day 2021. I also wish all of you a very happy World Meteorological Day 2021. As Kulshrestha was telling, the theme of this year's World Meteorological Day is the ocean, our climate, and the weather. If you just look at this theme, you might be wondering why this theme, what is its importance. its specific importance comes from the fact that this year, United Nations has declared the decade of science, ocean science for sustainable development, that is 2021 to 2030. This program is being spearheaded by UNESCO's International Oceanography Commission, and hence WMO is a party to that. So when I say WMO is nothing but a combination of national meteorological and hydrological agencies. So therefore, in every country, people try to maximize the effect to reach out the benefits of the research in the interactive process of Earth, ocean, and atmosphere. As all of us know, weather has no boundary, or atmosphere has no boundary. So therefore, if we want to analyze weather at a particular region, we should have the information on weather over the entire globe. I want to mention here, when we consider the weather, I consider it as just a byproduct. Say if there is a thunderstorm, or there is a cyclone, or there is a heavy rain, I feel this is just a byproduct of the various types of complex interactive process arising out of the Earth, ocean, and atmosphere. Now, if you look at the heat budget or moisture budget, you will find that ocean is a dominant player in this interactive mechanism, because 70% of the area is covered by the oceans. So ocean is a major source of heat and moisture, basically because of the fact that there's plenty of water and moisture, and also the water has the higher heat capacity, and hence ocean can absorb more heat, can retain it, and therefore that heat can be used again to increase the atmosphere temperature. So therefore, when the understanding grew over the years, people thought that we should have an interactive coupled approach to understand this ocean, atmosphere, and land-based weather phenomena. And that has also been imbibed as a culture in Indian scenario. The Ministry of Earth Science was established with this fact that you cannot divide Earth, ocean, and atmosphere into three different components. Even sometimes the biosphere also are a part of it. So therefore, entire Earth system science has to be addressed if you really want to address various types of natural hazards and its mitigation. So accordingly, you will find now that in the Ministry of Earth Sciences, there are establishments dealing with the atmospheric science, oceanic science, and the earth science as such. And all these institutes are working together, and there is an established coordination mechanism so that there can be exchange of observational data, exchange of the model output, hence the coupling of the various processes, and finally the forecasting and warning systems. That is the reason why in recent years, if you just look at, there has been significant improvement in the service of Ministry of Earth Sciences in terms of weather forecasting and what. So with the theme of the ocean, weather and climate, I want to say that ocean has a long memory, unlike the earth, unlike the other parts of the globe. Because of this long memory, the observations taken from the ocean, for example, the sea surface temperature or ocean thermal energy, can be used as a precursor to provide long-term predictions. So when you think of about the prediction, there are various ranges of predictions. You have the predictions in very short range, called now forecasting for a few hours. You have got short to medium range forecasting up to say 5 days or 7 days. Then you have got extended range forecasting, say for 1 week to 4 weeks, and seasonal forecasting, that is beyond 1 month and maybe 3 to 4 months or more. And thereafter, people are now thinking about the monthly, about the annual forecast and decadal forecast, proposed forecast in climate change based on our system models. So when you go for the longer lead period, certainly you cannot go ahead without observations on the ocean. And ocean is data first. So therefore, the first and foremost thing to improve our forecasting in weather and climate scale is to enhance the observations from the oceans and observations from the land surface. Considering especially India, it is such a region where we are bound by the Himalayas to the north, Bay of Bengal to the east, Arabian Sea to the west, and Indian Ocean to the south. Apart from that, we have got the Thar Desert in the northwest, over the Western Ghats, along the west coast, Eastern Ghat, along the east coast, we have got Chatnagpur Hills, we have got Myanmar Hills, we have got the Garo Khasi Jayantia. So these hilly areas are also the data sparse. So over the years, therefore, the objective has been to increase the observations either directly or the remotely sensed network so that we can maximize the observations. Because in forecasting the Earth system processes or the atmospheric processes, I have to say that the process is completely non-linear, and hence it is based on the principle that forecast is an initial value problem. If you can detect well, you can predict well. So when I say detection, that means detection through observations. Therefore, worldwide, people try to improve the observations, and hence you can simulate realistically the current atmosphere or current ocean, and that can be used to predict the condition of atmosphere and ocean, and hence the weather terms in future, say after day 1 or day 2 or day 3 or day 4 or after. So when you consider this type of prediction systems, where in the climate scale, there the role of ocean becomes more important because it has got higher memory. Hence, these observations can be utilized to go for the longer period of observations. So therefore, nowadays the focus has been not to go for only the atmospheric models, but also a combined atmosphere and oceanic model, that is coupled model. You'll be happy to know that in India also, for long range forecasting, we have got the coupled model. For certain extent range forecasting, we utilize the coupled model. And also for short range forecasting, even we have got the coupled model, hurricane weather research and forecast model meant for cyclone forecast. So what I want to say that there are various dynamical modeling approaches in the world to address the interaction between ocean and atmosphere, and hence to provide the forecast of various phenomena in weather and climate scale. And India Meteorological Department and Ministry of Earth Sciences are also at par with other leading centers. Now, if you look at the economy of the ocean, you will find that about 6 billion people are dependent upon the oceans. If you just consider 100 kilometers from the coastline in the world, you will find there are about 6 billion people who are dependent, therefore, on the coastal phenomena. It is not simply the hazards which has to be safeguarded, but also the marine lives, and hence, accordingly, the productivity of the ocean, because that is the life and livelihood of the coastal population. If you go by the economic terms, you will find that it is about $3 to $6 trillion US dollars, which is governed by these marine products, or you can say ocean economy. And it covers almost 3/4 of the world trade. So therefore, the entire economy, if you want to think of to improve further, there is a source. That source is the ocean. Considering that our Honorable Prime Minister has brought up the idea, the blue economy, it is a worldwide idea. It is being implemented in India also, and the Ministry of Earth Sciences has taken up the program for deep ocean research. I'm talking about the deep ocean research because there are the wealth of information inside the ocean, even near the Indian coast. We have got a lot of minerals which can be explored. We have got oils which could be explored. We have got the drinking water which could be explored from the saline water. the Pro Minister for Sciences were converting the saline water into drinking water in Lakshadweep near to Tikari. And also you have got the plants, the power plants, their energy also can be utilized for that purpose. You have also the tidal energy. So you have got the wind energy, and also you have got the solar energy nearby to the oceans. So all these can be harvested well only if you have got the observations, modeling, and forecasting of the required weather and climate parameters for planning and also the execution of various energy harvesting programs. Now, if you come to the various of hazards which are occurring in the oceans, which are threat to the humankind and to this blue economy, you will find that there are a lot of hazards. At the top for our Indian region, if you just look at, we have got the monsoon. The monsoon is affected by the atmosphere-ocean coupled process, or I will say atmosphere-ocean and earth coupled process. And one of the important interaction which has resulted, which has been established, is the El Nino and Southern Oscillations. Way back in the beginning of 1923, Walker came up with the idea that there is a water circulation, and also there is a seesaw in pressure between Tahiti and Darwin. And at that time, it was called a Southern Oscillation. And afterwards, it was found that this pressure oscillation in the atmosphere is not independent. It is related with the sea surface temperature fluctuations in the western part of the equatorial Pacific and eastern part of the equatorial Pacific. And that whenever the temperature is high over western equatorial Pacific and low over eastern equatorial Pacific, it's called as La Nina. And when it is higher over the eastern equatorial Pacific, less over western Pacific, El Nino. And people came to know that El Nino and Southern Oscillations are not independent. They interact with each other. Hence they coined the term ENSO. This ENSO is not limited impact with respect to Pacific Ocean, but it has got large impact throughout the globe. Considering Indian region, the monsoon is highly impacted by the condition of El Nino or Southern Oscillations. So therefore, we give a continuous watch about the development of this. It is not only India, but also even the South America, and the Venezuela, Brazil, Chile, they also look after this development, and they pray God that during December, that there should not be the birth of this new child, that is the El Nino, because it occurs usually in the month of December, and this is the birth of Jesus Christ, month of Jesus Christ's birth. So they will be praying God that it should not happen. If it happens, El Nino, then these South American countries get very severe thunderstorms. This severe thunderstorm leads to the loss of lives and property. And at the same time, this leads to the warming of sea surface, and hence the fish migrate from the coast into the deep sea. As a result, the fish catch is hampered, hence the economy is hampered. So in Indian scenario, it also has the impact in terms of the heat waves, in terms of the cold waves, in terms of the monsoon, in terms of tropical storms intensity and its frequency. So therefore, the ocean cannot be judged separately and the earth. So we have to take into consideration. Apart from the El Nino Southern Oscillation, there are other coupled phenomena like Indian Ocean dipole, where we have got a difference of heating over the West Equatorial Indian Ocean and East Equatorial Indian Ocean. When West Equatorial Indian Ocean is warmer and East Equatorial Indian Ocean is cooler, that is called as positive Indian Ocean dipole, and that favors the monsoon condition. If opposite, it is not favorable for monsoon conditions. Similarly, there are other oscillations like North Atlantic oscillations. You got Atlantic decadal oscillations. So all these are also associated with the weather phenomena occurring in Indian region. So therefore, the objective is to have not only the observations from the ocean Earth atmosphere locally, but also globally. And for this purpose, the World Meteorological Organization acts as a coordinator. It facilitates the exchange of data among the countries. It facilitates the capacity building of the countries, especially the least developed countries, island nation countries, with the transfer of technology from the developing and developed countries to these countries. It facilitates the development of numerical models and its utilization in forecasting. It facilitates in warning dissemination. So therefore, the rules and regulations, guidelines, practices, standard operating procedures, whatever is required to carry out this global monitoring, and hence forecasting is ensured with this network of world meteorological organizations. Within that network, certain countries play a dominant role. So, for example, India plays a dominant role as a regional center to provide weather forecast and civil guidance to many countries in South Asia, Southeast Asia, and Middle East. We also provide forecast for cyclones, heavy rainfall, thunderstorms, waves, surges for all these countries. So by that way, to carry out all these things, which we have seen in recent times, there is a significant jump in forecast accuracy and period, leading to minimization of loss of lives and property due to these severe hazards. So it has been possible because of this interactive approach of the Ministry of Earth Sciences. We have a collaborative R&D, not only within Ministry of Earth Science, but also with many organizations within the country and outside, with the IITs, JNU, ISC, and many other academic institutes. And also we have got international collaboration to carry out that. At the same time, we have invested technologically to improve the observational systems with augmentation of automated weather stations, augmented rain gauges, Doppler radars, and satellite system. We have gone for high power computing systems to improve our computing power so that we can run the global models, regional models, and ensemble models to provide holistic forecast. You'll be happy to know that India is the only country where you have got the ensemble model and the diffuse model with the same resolution of 12 kilometers, and we have got two ensemble modeling system. And also you'll be happy to know that India is fourth in the computing power with respect to meteorology after UK, USA, and Japan in terms of hypercomputing system. We have got 10 petaflop system, but it is not sufficient. We have to go to improve further to meet the requirement of the various stakeholders. Now, coming to I will say the inspiration what we get from the ocean, which is a source of wealth, which has to be discovered. So, Ministry of Earth Science has taken up the program for deep ocean research. But at the same time, I will tell you, due to this ongoing climate change, whatever Kulshrestha was referring, there has been some imbalance with respect to the heat and moisture balance, or you can say the water cycle, changing water cycle. Now, for example, if you consider the heat, because of the global warming, there has been some excess heating. And where is that excess heating going to? Who are the sources which can absorb this excess heat? If I compare the Earth's surface, ocean surface, the ice sheets, glaciers, etc., we'll find that ocean has got the capability to absorb 90% of this excess heat. As a result, our atmosphere, or Earth's surface, is getting only 2.3%. So therefore, if you just look at the sea surface temperature and Earth's temperature changes over the period of say 100 years, you'll find that the rate of change in the surface temperature of the sea is quite high as compared to the land surface. So that is the manifestation of the fact that sea is absorbing more energy as water has the higher heat capacity. But at the same time, since it has got higher capacity, it can also emit, and therefore amount of moisture which is being released to the atmosphere is increasing. At the same time, this increase in temperature is not limited to the surface, it is also propagating to the troposphere. So therefore, the moisture holding capacity of the atmosphere is increasing over the years. Due to this increase in moisture holding capacity, as and when you have got the higher sea surface temperature because of this phenomena, you have got higher possibility of the convective activity, and this convective activity will be more intense because of the moisture holding capacity which has gone higher in the atmosphere. As a result, if there is a low pressure system which is moving during monsoon season from head of Bengal towards west northwest towards across Odisha or West Bengal and Madhya Pradesh, that low pressure system will have a higher capacity to cause the more rainfall. It is established that the frequency and intensity of heavy rainfall events are increasing. This is not the fact only in India, but globally, over the tropical region, the frequency and intensity of heavy rainfall is increasing whereas the light to moderate rainfall days are decreasing. So that creates the scenario where you can expect a flood-like situation because of the flash floods. It will have the problem with the cities especially. And Israel established also the urban area are getting more heavy rainfall events compared to the rural areas. So therefore, what I want to say that though ocean is helping us by absorbing the maximum energy from the insolation, but it is also creating a threat. It has certain limit. If you go on increasing the sea surface temperature, the probability of higher convection will increase. Hence, more intense thunderstorms, more intense cyclones, and more intense low pressure systems, and hence heavy rainfall event during monsoon season can be expected. At the same time, if the sea surface temperature goes on increasing, then there will be melting of sea ice, melting of glaciers, etc. It is found that during past century, there is an increase in sea surface sea level by about 15 centimeters. And if you go by the target fixed by Prof, Paris, Paris, just remember that 2 degrees Celsius we should maintain. And if our projection is maintained within 2 degrees Celsius, then sea level rise projection goes up to 60 to 70 centimeters. So therefore, you can have the hazards associated with rising sea level, especially in the coastal areas and also the islands. At the same time, when the temperature is rising over the sea surface, this rise in temperature leads to, you can say, the decrease in oxygen content. At the same time, ocean is a sink for carbon dioxide, and carbon dioxide intake for the ocean is increasing, and hence there is acidification of the ocean. So you have both the problems environmentally. One is acidification because of the higher intake of carbon dioxide, which is also increasing gradually, and the other one is the decrease in oxygen content. So both these phenomena will adversely affect the marine life, flora and fauna, and hence the marine products or output from the marine sources. It is established fact. So if we just take an example for the marine resources like fish, certainly the temperature increases, the fish availability in the upper surface will go on decreasing. They need to go for deep layer fishing. When you go for deep layer fishing, there will be certain issues with respect to conservation of the ocean. So there are other issues also with respect to ocean, say for example pollution because of various types of waste materials being thrown into the ocean, especially the plastics. And hence the objective is that we should have a safer ocean, we should have a predicted ocean, and also we should have a transparent ocean. If you can have these three, safer ocean by the way of providing the forecast and minimizing the impact of the global warming, and predicted ocean, that means you can predict well all the features of the ocean well in advance and accurately so that this information can be used for management of natural resources and management of natural hazards, and transparent ocean for minimizing the pollutions. So there is a long way to go for each of us, and I'm happy that ENVIS has taken off this subject on the day of on the World Meteorological Day. I hope it will certainly, this theme which has been taken up, will raise the questions in the mind of the young ones, and it will ignite them to take up the research work to address all these issues in our environment and hence the ocean, weather and climate. On the day, if I look at the systems which we have, I can tell you that India is well equipped with a number of meteorological buoys nationally and also through international network. We have the specific ships put up in the oceans. We also have the SCATSAT and INSAT 3DR, SCATSAT 2 is also coming up, which are also providing this data of the oceanic data first region. Also, we have the coastal Doppler radars. Entire coast is now covered with the Doppler radars. So therefore, the observational network recent years has improved, but still there is challenge with respect to augmenting this network in the ocean. Because the ocean is vast, so we have to increase the density of the vessels. At the same time, the assimilation of data in these oceanic models and improvement of forecast of the oceanic model is still a challenge. I want to say that though the India Meteorology Department and many global centers predict the evolution of El Nino and Southern Oscillation, the predictability of this oceanic phenomena is still less. So we have to go a long way to predict the various features. That means you have to not only predict the output directly the weather, but you have to go to predict the physical processes, the dynamics, and hence finally the forecast of the severe weather and the climate phenomena. So therefore I will tell you that we have to go for further augmentation of the observational network, modeling, especially the coupled modeling in different aspects, starting from regional coupled to global coupled modeling, or very few hours forecast to up to seasonal forecast, and then decadal forecast in our system processes. Then we have to go for marine impact-based forecasting. Perhaps some of you might have listened about the marine heat wave. This rise in sea surface temperature can also lead to heat wave conditions. We experience heat wave over the land, and we know basically heat wave is a condition which becomes fatal if a body is exposed. Similarly, in the ocean, if our marine life is subject to the marine heat wave conditions, there will be loss of lives. And also the marine heat wave conditions also will impact the lives of our fishermen, our shippers, all the people, those who are put up in the oceanic environment. So for impact-based forecasting with respect to and marine environment, we have to improve our research and development in a collaborative manner, involving many national and international organizations. We have to go for an awareness campaign. People should understand whatever basic knowledge we have. People should understand that. People should act upon that. For this purpose, there is a need for massive awareness campaign with the coastal population, mariners, fishermen, nearby agriculture farmers, and many, and even the media persons in general. We have to go for the capacity building. When you go for capacity building, I'll say there is need for capacity building for the forecasters, capacity building for the planners, climatologists, and also oceanographers, and many more. So therefore, there is a long way to go for, and by that way, India Meteorology Department in Mr. Consensus is taking up various initiatives addressing all the components of this weather and climate system. And I am hopeful in future we will continue our march towards improvement weather and climate services, and hence to help in improving our socio-economic conditions and minimizing loss of lives and properties. I once again congratulate all of you on this World Meteorological Day and wish you all the best. Thank you.
Thank you, Dr. Mohapatra, for very elaborative feedback, sharing your research, and also new challenges what IMD has. In fact, I should add to this that the acidity of the ocean is increasing, especially not because CO2, but during winter time, that is due to continental interference and transport of pollution, that's sulfate and SO2. And then I was part of Indian Ocean experiment. 4 years we used to go to deep Indian Ocean, Maldives and Mauritius and that region. So we found that January to March period, there's just too much acidic precipitation was there, not monsoon. So the monsoon is relatively better when ITC ships are. So from that angle, role of IMD and especially the program GoV, Global Atmospheric Watch, that has been very interesting, and we have contributed to the quality system means as a team member to the GoV precipitation, all this. So when I was very young that time. So I am happy that you have mentioned that certain thing in ocean, and as you said, rightly said, we need to have coupled modeling and strength development, especially for. But what is very wonderful thing for IMD, things very great services for weather and climate. IMD is providing to India and neighboring countries. So it's really appreciable, and we look forward for many more because when you have this kind of networking, monitoring, you interact people, so kind of social also, social engineering also is possible from that. So in this, now once again I thank Dr. Mohapatra, and now I invite our eminent panelist, Dr. Professor A.P. Dimri. Before that, brief introduction of our panelists, I would request our participant to write their queries and questions in the chat, and then I can ask the relevant questions to the panelists. Now, as you know, Professor A.P. Dimri is a well-known meteorologist. He is a faculty of our school, School of Environmental Sciences. He is working on regional climate modeling, climate dynamics, climate change. He is fellow of National Academy of Sciences and Japan Society for Promotion of Science. He got several other, he is editor of several journals. Earlier he was in DRDO, and then he joined JNU. But he is a JNU alumni, long back he did his education from JNU. He has a lot of international papers, and recently has got very best of his papers recently. Mr. Dimri is very dynamic, as you know. He doesn't need much introduction. Before that, I welcome him, and also I thank him. In spite of his very busy schedule, he accepted. And now I request Professor Dimri to share his experience about meteorology and say a few new things to our students. Professor Dimri, please.
Thank you, Professor Kulshrestha. Respected Mohapatra sir, respected Professor Ganguly, Professor Kulshrestha, invitees, and my dear friends. I congratulate you on World Meteorological Day. World Meteorological Day is also, in my understanding, and maybe to celebrate the services, human services to the nations, to have the society safe. In our context, it's India Meteorological Department, to provide forecast in time, to save the society. So this is also a day when we should celebrate their success. There are other services, water services, there are climate services. So this day definitely leads us to celebrate their success story with society. All services doing very human services with this context. And if you go to the Meteorology Day in particular, this 2021, this Meteorological Day theme is, of course, as it's debated oftenly, and I'm listening from today many talks, the ocean, our climate and weather. Professor Mohapatra gave a very good amalgamation of this coupled system. And we have to understand through innovative and transformative ideas, the basis information to support the sustainable development of the societies. And that's what is these agencies for understanding climate, weather, water, disaster, and it strives to support understanding these very, very complex, inextricable link between ocean, climate, and weather. By virtue of that, ensuring safety at sea and land, as he mentioned that almost 40% of communities live within the 100 kilometers of the coastline globally. So this context is very, very important, that how the ocean shapes weather and climate. Any one of you, if try to get the hold of Captain Cook's voice, he has done a very three wonderful voyages from Scotland and England, and he came to know across the various other continents. He came to Rio de Janeiro, he came to the Indonesia, he came finally to New Zealand, found New Holland. And what I mean to say that ocean remain a very, very important route in the context of trade from very, very historical memories what we have. We have a climate, if you look, weather in particular, we have a Silk Route, which is crossing right from Tibet to the Middle East. People used to go for trade, and knowing the good weather was very important. If you look the winning or losing of the wars, weather played a very. So what I mean to say that even after knowing the complexities associated in these processes, which are very complex in nature to understand, there was always an evolution to understand these processes better and better, where these services are doing very important job and important human services by using the coupled models, oceanic coupled model. Of course, there is evolution of coupled models happened 1970 onwards, and now even they are having a defined scale. So knowing this thing, and the latest, if you look at the context of ocean, we have a Indo-Pacific dialogue. So ocean has come in the geopolitics also. Of course, he has mentioned the blue economy. A lot of things are associated with the oceans, and that's what is the theme, that how these things individually and together will form a kind of integrated view to understand the weather system, complex system. And then there is a national mission. If you are following it, 2 days before, we have a very important announcement from the national mission of water: catch rain where it falls, when it falls. It means that water is going to be a very important ingredient for the blue economy. Almost roughly 6 million people are involved with this kind of thing. And if you go to the prediction system, particularly I will come to our region of Indian region. If you go to the monsoon system, we have a Meghdutam. There is a known way of deliberating on how the coming in that time. There is a who has said that how the monsoon has arrived, and he gave a name in the Arabic, and then with Aram here, we has given a Varsa Sambat, where you have a calculations how to, and then coming to the latest, these calculations based on the high computing facilities model, which are coupled in this. So in a way, if you look in the processes of the meteorology, in the fundamental process of that, everywhere we have this kind of changes which are captured in it. Now, the importance is of enhancing the global basic observing network, in the sense that where we have a better observation, placed in innovating financing facilities also, because there is a lot of capacity build up. Mohapatra is a tropical cyclone expert. If your oceanic are warming, we have repeatedly recorded Atlantic hurricane season. Even this year also, there is a hurricane season, winter time, and the usually intense tropical cyclone in Indian and South Pacific Ocean. So, and then storm surge damages across the coastal line. So these are the storms which are kind of devastating impact on the coastal communities, and coastal communities who are very much dependent on sustainability on the coast and associated. Non-tropical ocean storms also continue to wreak havoc abroad ships, and there are many more incidences where the people are talking of the warming of the water. Polar communities will suffer because of abnormal coastal flooding. So these indicates that how meteorology, in the sense of sustainable development, has to be done, and hence this becomes a very major stake of this community in to support the research, observations, prediction, and services for understanding the atmosphere, land, and ocean together. There is a major gap area in the ocean. Of course, there is a very good network of meteorology as far as the Indian land continent is concerned. It is growing and growing in time. There is very good weather forecast is also coming with the time. I will not go through predictability issue, already is touched upon by Professor Mohapatra. But then in particularly, there is a need for open earth system data for the researcher, which is happening with the data, and I am very happy to share here with students in particular. This year, I think, correct me, Professor Mohapatra, if I'm wrong, they have a IPCC one model is included. from the Ministry of Earth Sciences. So that's a very important contribution coming from each time. And then Decade of the Ocean Science of Sustainable Development is going on 2030 to 2021 to 2030, and WMO is committed to contribute with much of a ocean, transparent ocean, which already touched upon. So together with partner with various WMO organizations, there is a need to understand the weather and climate with the forcing of the ocean. They understand there is a need to continuously working on that, how the ocean shapes weather and climate. That's very important because there is a interaction at every scale, and oceans very tightly linked to the atmosphere process, various elements. All these processes are debated upon. There's a Pacific Decadal Oscillation. So keeping in that line, and then there is a context of sea level rise also because of melting, maybe polar ice melting, and there are enormous horizontal and vertical oceanic current within the ocean and coupled with the atmosphere also. So this is the kind of energy exchanges which are happening from equatorial region to the pole region and vice versa. It's happening, and there is a kind of a going ahead and going back kind of a thing, and then ocean warms, cools more slowly than atmosphere, and this warming and cooling with atmosphere definitely had a certain kind of a lag. If you include the land also, there is also certain kind of lag, but the processes are coupled from each other. There is a kind of exchanges occurring in all these domains, land, ocean, and atmosphere. We have to understand that how the tropical and extratropical region are making more storms or events more intense, or they are weakening, if that is so. So that is the kind of heat mechanism, like because of the sun-earth system, almost 90 to 80% heat is trapped by earth by carbon emission. I will not go in that. Carbon emission is stored in the ocean, and particularly very less, 4 to 5%, I think, warms the atmosphere, while the rest melts snow, ice, warms the land, and simultaneously ocean also interacts with the atmosphere, and that is one of a good example of Indian summer monsoon. Having said that, with the changing warming pattern, is there an impact on the Indian summer monsoon dynamics? We yet to see that, and if it is so, what are the couple processes due to the impact of climate change happening? 1.5 degree warming, 2 degree warming, 4 degree warming, how this excess heat contributes these interactions due to the thermal expansion, anoxic ocean area, melting of sea ice, and so on and so forth. There can be a heat wave is very important in the summer time, and in winter time there is a cold days also are increasing in some of the regions, right? So these are some issues that has been evolved with the understanding of the previous to present and even future also. There are good amount of predictions are given on this context of this challenges and understanding of the ocean observation and research and services. With this overview, if you look at this blue economy and sustainability use of the ocean resources, this will be very much, if you are looking from the health of ocean in the context of blue economy, which is kindly debated some years ago based on the World Bank report and the European Commission, how this blue economy is kind of exploitation and preservation of marine environment both, because a lot of trade happens through these oceans. Almost 90% of freight trade occurs through ocean, so a lot of economy is involved there, and there are various organizations are involved in that, and they generally use the scope of the international development and exchanges also occur for describing sustainable development and approaches. There is a context of the renewable energy. There is a context of worldwide water, wildlife, the life below the water. I mean that how these important issues are kind of working in that. We have a very good example from historical Roman period, Hellenistic period, Austronesian maritime trade network. All the trade network which used to happen, the trade routes at that time, island of Southeast Asia, they opened the first open ocean going ships, and then how this ocean going set, they established trade in southern India, Sri Lanka, as early as I think 1400 BC. They are exchanging maritime culture. A lot of stories we have heard already in our context of spices getting exchanged, and many other fruits are getting exchanged. And if you look at the human evolution also, how the humans transcend from one place to another place, from African side, there is a archaeological and paleoclimate studies has been proved that how these oceanic movement along with the plate tectonic of work as a maritime silk roads. That's where is a very important context coming in the blue economy. And then if you go back to the Harappan and Mesopotamian civilization as early as mid-Harappan time, roughly 2600 BC and before, civilization came, they died because famine occurred. Again, another process. Most of the civilizations in previous time, Babylon and other civilizations also, they were closer to the river, flowing river for sustainability. But what happens in the due course of time, there are a lot of weather processes occurred which led to sinking of their society. In this context, if you look in a cohesive manner, that all the processes are integrated in a form in one way or other in the context, and if this context is understood well in the present time, so we have to learn from history. That learning we need to convert into how this can happen, and the society has also a very big role in this conversion of one and understanding to another understanding into the picture. And also, if you look at the deep ocean research project, is coming very good initiative has been done by ministry, and also very good important efforts are given on networking of the data, which I think most of the young researchers, even I also use for my research from Indian Meteorological Department. So they are the very important observation in the context of what previously has happened. And there is a very good by Richard Kaplan on monsoon. It's not the monsoon what meteorologists say. It connects that how the monsoon is so important economically, of course, India, but how that monsoon, he explained that this maritime trade route were captured knowing the good weather and bad weather. And he has very explicitly explained that how in the historical time, the evolution of monsoon has come up in the context of the trade and how the society moved from one place to another place. Another good book has come on the Indus Basin very recently by Uttam K. Sinha. He has given a very explicit example how this deviation of Indus River in the Indian territory and then following by flowing to the lower riparian of the region of Indus Basin has presented the theme of the historical period, that how rivers are very important for the society to go with. And in this understanding, if we look from these processes point of view, that's very, very important. Very good point was raised that if the moisture will be held up in the atmosphere for long, is that happening? And then if it is so, what's going to happen to the water hydrological cycle in the free atmosphere? Because hydrological cycle is one of the very key cycle where you can't construct water, which if there could be a possibility of having a factory of water. So you have a limited balance in that context. And if this new initiative of Catch the Rain gets successful, where all society has need to be participatory, whatever scale it can be, and if that attains for longer time, it will be a good amount of sustainability for the general generations to come. And that's what is the theme of the World Meteorological Organization also. In view of this, that if your heat trapped in the atmospheric system, if you are talking in that sense, then how this meteorologist, oceanographer, and all other researcher, even I came to know today, IIT Delhi has opened a very good observation system somewhere in Sonipat. I think
going to be. Hello?
It's going to be.
going to be on 25th.
We lost Professor Dimri.
Connection lost. No issue. We can wait. But meanwhile, if he is not able to come, then I thank Professor Dimri for his valuable feedback, research. In fact, he has updated for many things about ocean meteorology, climate change related issues. I think you students can take note of that. Our young panelist, Dr. Dilip Ganguly. So, Dr. Dilip is associate professor.
I am back. I think
If any question is there, I will pass on to you. And thank you very much, Professor Dimri. And now I am welcoming Dr. Dilip Ganguly. And he is associate professor at the Center for Atmospheric Sciences, IIT Delhi. He is very calm and very sincere worker in climate modeling. He has his research interest in climate modeling, aerosol cloud, precipitation interaction cloud, parameterization, air pollution, and atmospheric chemistry. Dr. Ganguly is basically passed out from Kolkata University, DHU, and PRL ISRO system. He is output of ISRO system now working for climate dynamics. He is a member of American Geophysical Union, member of IASTA, Indian Aerosol Science and Technology. He is a member of Indian Meteorological Society, IMS. He had graced various professional positions in his career, starting from research scholar to assistant professor to now associate professor. He has been recognized and awarded Dr. Sudhanshu Kumar Banerjee Outstanding Award faculty, then postdoctoral research fellow. So many things are there available on his webpage. He has wonderful publication, very good academic basically impression. He is very famous in among this student category. Without wasting much of the time, now I request Dr. Ganguly to say a few words and inspire our students on the government. Dr. Ganguly, please.
Thank you, Professor Kulshrestha. First of all, I want to for that introduction, and thank you very much for inviting me to this panel discussion on the occasion of World Meteorological Day. And Dr. Mohapatra and Professor Dimri has already set the tone. Wonderful discussion we already had. So in that, I just want to continue that discussion a little bit further and relate it to my research interest basically. So all of you, as you know, that according to reports published by NASA and some already papers published, that last year, the year 2020 was already the warmest year recorded. Of course, it was a joint warmest record year along with 2016. But the interesting thing is that 2016 was a strong El Nino year, whereas last year towards the end there was some cooling due to La Nina. Despite that, it was the warmest year recorded for whatever number of years temperature records that we have for our planet. So this warming Obviously, we have seen that it has resulted in several extreme events across the globe, like heat waves, extended droughts, coastal flooding, and of course, disappearing Arctic, Antarctic, and sea ice, as well as mountain glaciers. And now there are several research papers that have been published in the last decades where people have shown that this rising temperature also uh, is, of course, it is related to global warming. Increase in, we are emitting more greenhouse gases than ever before. But these extreme events that have been observed across the globe are also related to air pollution. Now, air pollution means emission of unwanted gaseous and particulate matters into the atmosphere. So these particulate matter are known as aerosols, and that is actually So my area of research interest is to understand how air pollution impacts climate change as such globally, and especially over the Indian region, Indian summer monsoon, etc. So aerosols, as you know, that these are tiny solid particles or liquid droplets that are suspended into the atmosphere. There are a variety of sources of aerosols. They are emitted from both natural sources as well as due to human activities. Some are primary aerosols, some are secondary aerosols. That means we are emitting some gases which then convert into particles through after undergoing some kind of reactions, physical and chemical reactions in the atmosphere. And once there are different types of aerosols like black carbon, sulfate, organic matter, nitrates, dust, they can mix with each other. And this mixing is also of different types: external mixing, internal mixing, or core cell type of mixing. That actually makes it very difficult for scientists to estimate their impact on climate. So now these aerosols are known to affect the climate of our Earth in various ways. They are known to affect the climate directly by interfering with the incoming solar radiation or outgoing infrared radiation, as well as they are known to influence the microphysical properties and the lifetime of the clouds that are present in the atmosphere. But all these processes ultimately influences basically the atmospheric heating pattern and its temperature structure, and therefore they are able to influence the climate. Now, when it comes to the last IPCC report, or even several other research papers that have been published in the last decade, they have shown that because of this direct and indirect effect of aerosols on the climate, it produces an overall cooling effect on the global mean climate. However, there is large uncertainty in basically in the estimates of how much cooling it produces across the globe, because there are uncertainties associated with the emissions of aerosols from different sources, and the representation of these aerosols in models which are actually used to estimate their impact on climate. And people have also said that aerosols have large uncertainty on, and there is large uncertainty about the aerosol impacts on climate, but there is even larger uncertainty regarding the aerosol impacts on the clouds and ultimate impact of the changes in the clouds on the climate system. So now one has to know that not only the aerosols are able to change the properties of the clouds, but also clouds respond to global warming. That means increases in greenhouse gases are also able to change the characteristics of the clouds that are present in our climate system, because as you know that increase in CO2 can result in warming of the atmosphere, so it can actually change the vertical temperature structure. It can make the atmosphere more stable, for example, and also when the temperature increases, the capacity of the atmosphere to hold the amount of moisture in it also increases. So ultimately, this influences the type of clouds that are forming in the atmosphere, and these clouds, they play a very important role in actually deciding the planetary albedo. So because planetary albedo, as you know, that it decides how much, what is the fraction of the solar radiation that is coming from the sun will be reflected back to the space. So if the amount of clouds change in the atmosphere, it can change the planetary albedo significantly, and aerosols and greenhouse gases both are contributing to that change in planetary albedo that is happening. Now, over the Indian region, basically, you all know that particularly all of us are from Delhi, so we know that in the Delhi NCR region, basically, there is a severe air pollution problem, particularly during the winter times when the atmosphere is totally covered with smog, leading to poor visibility, and there are lots of problems associated with that. In fact, according to World Health Organization report that was published last year, Delhi was considered to be the most polluted city in the world in terms of poor air quality. And in fact, if you look at that report, the last year's report, you will find that 11 out of the top 25 most polluted cities in the world, they are actually located in India. Different cities of India are among the most polluted cities in the world. So, and then there are studies which have shown that this poor air quality that prevails over India are estimated to cause several premature deaths. That is, it has adverse impact on human health, and also there are some studies published done by economists where they have shown that this poor air quality problem that we have over India is actually adversely impacting the economy of our country. I mean, according to some estimates, they are actually reducing our GDP by like 1.4% is affected by poor air pollution. So, and now the link between the global warming and air pollution is already known to us, and we need to pay more attention in our country to understand these linkages between air pollution and global warming and the climate change. And as you know, that India is also extremely vulnerable to the impacts of climate change and extreme weather events such as thunderstorms, floods, cyclones that are becoming stronger, more frequent. And so with the monsoon becoming more erratic in the last few decades, and extreme weather becoming basically more and more extreme weather events are happening every year. So IMD, actually India Meteorological Department, is actually doing a great job in predicting several severe weather events in advance in time, so that people can take, I mean, we can minimize the loss due to such events that are happening. But so what I feel is that in order to basically improve the, I mean, in order for us to strengthen our capability to predict the behavior of the atmosphere and ocean at various time scales, we need to we need to improve the capability not only in modeling but also in observations. So as Professor Dimri was mentioning, that IIT Delhi is coming up with a new atmospheric observatory that is going to be, so we are going to have the groundbreaking ceremony on 25th of this month, that is day after tomorrow. So Dr. Rajivan will actually inaugurate that facility. That is coming up in the Sonipat campus. In Sonipat, Haryana, we have a campus. So where that facility is coming up. So because we believe that although in Center for Atmospheric Sciences, traditionally so far, we have been mainly focusing on modeling, that is both atmospheric modeling and ocean modeling and Earth system modeling. But we believe that we need to also pay attention to observations, because simultaneous observations of air pollution and meteorology is extremely important for understanding these linkages between air pollution and weather and climate phenomena. And by observing basically air pollutants, greenhouse gases, clouds, and meteorology together and continuously, it is possible to transform science-based action and continuous and long-term monitoring of these air pollutants, clouds, and meteorological observations through ground-based as well as satellite observations can actually help us to understand how the air pollutants are formed in the atmosphere, how they are transported from one location to another, and how they impact the weather and climate. So, in universities like ours, like JNU or IIT Delhi, and various other academic institutions, in addition to government institutions like Indian Meteorological Department or IITM or NCM or WF, we should actually work to create more skilled manpower for the country who are capable of doing both observations and modeling, so that we can help the country in developing the capability to predict the behavior of atmosphere and ocean at various time scales, which are relevant for all kinds of weather and weather phenomena and climate change. Yeah, that would be all, Professor Kulshrestha.
Thank you very much, Dr. Ganguly. And before I say something, I request Professor Dimri if anything he wants to add, because there was some connection problem. Professor Dimri, please.
Yeah, it's perfectly fine. Most of the thing I have conveyed right from observation to the historical understanding what we have developed in the past, how to connect them in the present moment, improve upon the processes and be the future. So that is very good, and I congratulate you all again on the World Meteorological Day. Thank you very much.
Okay, thank you very much. So I now invite our young holistic leader Mudita Chaturvedi to say about her experience in YoHo program. She is involved since beginning. Mudita, please. She is doing PhD under my supervision on rain chemistry, nitrogen related especially. Mudita, please.
Good evening, everyone. Before saying anything about topic, I would like to inform views about YoHo group, which is like young holistic group of our lab people in our centers. Like we have developed a group called Young Holistics, in which we have multiple clubs for different activities like debate and discussions. We perform multiple activities in that YoHo under that YoHo club that was initiated by Professor Kulshrestha sir during his to create more awareness about environment, and to suggest and to try to propagate more of the holistic approach in providing mitigation strategies for the environment. So we work with our ENVIS team to organize. I myself was associated with the Yoga and Web Club, in which we have organized some yoga sessions also. And in web, we used to create more awareness through different platforms like Instagram, Facebook, and through multiple platforms, we used to create awareness about environment-related issues. So now about the topic which like World Meteorological Day, which is the ocean, climate and weather. So I myself is working in precipitation chemistry, where I have seen carbonaceous wet deposition of carbonaceous components and reactive nitrogen at multiple sites in country. So while thinking about the topic, I was very curious to associate that with my work, like ocean, climate, and weather. I was curious to associate it with my work. So while going through the literature, I came across data like 90% of extra heat that is trapped in Earth atmosphere due to more of the carbon emissions by anthropogenic activities and other activities is stored precipitation chemistry on continents like the this energy difference, which is the main reason of creating precipitation and everything, is responsible for so this energy disturbance creates rains on continents also. So like why if we see rain chemistry at multiple sites, like I myself have seen a site on Western Ghats, and my other sites are in Delhi and in Jaipur and Mathura, like in proper anthropogenic regions. So I have observed that the rain chemistry, like the deposition that we have received on Western Ghat, was much different than the sites on anthropogenic region. So these all things, I think I just want to add this thing, like all of the speakers which have spoken earlier have all of the professors which have spoken earlier have covered all of the points. Yes, I want to add this thing that the carbon emissions, which are extracting reason of extracting more energy and absorbing more energy in environment, are mitigated by the same intensified processes, same precipitation which occurs on land. So this is all I want to say.
Thank you very much. Thank you very much, Mudita. Wonderful that you have shared your experience about the YoHo program and also the theme of the World Meteorology Day. Now let me summarize, and after that I will ask Swati to provide a comment about it. So in summary, we can say that India is doing wonderful in terms of meteorological research, meteorological services, and it can fight with all vulnerable items. And we are monitoring, and now we have very mature science and technology. Even we are ready to procure more advanced tools to control our disasters and cyclones and extreme events in Himalayas, that kind of thing. It's the services are given in nearby countries. As Dr. emphasized, we need to have coupled modeling capacity. We need to develop it, and we have to strengthen our monitoring further. And then Professor Dimri emphasized for hydrometeorology research and take benefit for society, and also the relevance of dynamics, climate dynamics is not studied. And definitely our panelist, Dr. Ganguly, he emphasized very important part, that is the aerosol cloud interaction and aerosol health issues. a very important one because these things are controlled by Meteorology. Our young holistic leader also emphasized same thing, and especially she compared Western Ghat with the very polluted region, because Western Ghat is very it is reserve forest area, and then compare with Delhi scenario is very much different. It's almost sometimes some parameter they are 1/10 or 1/5. So with this, I think it has been very useful event. I thank all the panelists, Dr. Mohapatra, Professor Dimri, Dr. Ganguly, Mudita. They have created the occasion. I think it's very useful. Maybe if you have any feedback, queries, to write to us. We will ask our expert to reply. And now I thank all ENVIS team. Swati, she is very dynamic program officer. Swati, please propose vote of thanks.
Thank you, sir. First of all, I would like to congratulate everybody on the occasion of World Meteorology Day. And I think it was a very successful event that we had been able to conduct today. And with such senior professors and senior bureaucrats working in this area. So first of all, I would like to thank Dr. Mrutyunjay Mohapatra, sir, for his insight and I think the experience and detailed that he shared with all of us, the students and the young researchers have gained a lot of areas which are still demanding their contribution, and the overall holistic approach that he had shown and how the ocean, atmosphere and land coupling is important. Then Professor A.P. Dimri, sir, thank you for your insight and the historical as well as the recent views that you've shared, the various trading routes. I think a very new and different approach that we've got to understand. Then Dr. Dilip Ganguly, sir, thank you once again for your research and your experience that you've shared. Thank you, sir, so much. And Ms. Mudita Chaturvedi, she's a young holistic leader and very well she has shared her work experience and the YoHo activities which she is part of, and the whole, I think a lot of students from SES and ENVIS together are doing, contributing to this YoHo group. And last but not the least, I would thank from bottom of my heart to our coordinator, sir, Professor Kulshrestha,